Welcome to a journey through time that explores one of the most profound ideas in human history, atomism. Today, we will trace its development from the bustling heart of ancient Greece, where early philosophers first dared to imagine the world as a tapestry woven from innumerable, indivisible particles, right through to the revolutionary discoveries of modern science. In this narrative, we discover how a radical idea evolved over centuries, shaping our understanding of nature, matter, and the very structure of reality. Our story begins in the vibrant intellectual atmosphere of 5th century BCE Greece. It was here, amid debates about the nature of existence, that Leucippus first introduced the concept of atomism. Leucippus set forth the daring idea that everything in the universe is composed of minute, indivisible particles he called atoms, and that these atoms exist in a vast, empty space, a void. This was not just a statement about physical matter. It was a bold philosophical stance that challenged the prevailing views of order and divine intervention in the cosmos. Building on these groundbreaking ideas, Democritus, a student of Leucippus, refined and expanded atomism into a comprehensive philosophical framework. Democritus argued that atoms were solid, eternal, and varied only in size, shape, and motion. He likened these particles to tiny building blocks, each moving through the void, colliding and combining to form the myriad substances of the world. In Democritus' vision, the universe operated according to strict natural laws, where every event was governed by necessity, leaving little room for divine purpose or supernatural influence. This early formulation of atomism was revolutionary. It posited that the complexity of the world could be explained entirely in terms of simple, natural components. The notion that all matter was composed of minuscule, unchangeable parts laid the intellectual groundwork for much of later scientific inquiry. Imagine, if you will, a world where the mysteries of nature were not attributed to the whims of capricious gods, but rather to the inherent properties of the tiniest elements of existence. It was a radical perspective that set the stage for centuries of inquiry and discovery. With the philosophical seed of atomism planted firmly in the fertile grounds of Greek thought, the narrative of this idea continued to unfold. As time passed, the framework of atomism began to weave itself into various strands of intellectual and cultural development. The next significant chapter in our story takes us to the era of Epicurus, the ancient philosopher known not only for his ideas on pleasure and happiness, but also for his remarkable adaptation of atomistic theory. Epicurus, living in the 4th century BCE, took the foundational concepts outlined by his predecessors and used them as a stepping stone to formulate a more nuanced understanding of the natural world. He maintained that the universe was compatoms moving inexorably through the void, yet he introduced novel ideas that would have a lasting impact on both philosophy and science. One of his most notable contributions was the concept of the swerve, a small, unexpected deviation in the path of an atom. This deviation, though seemingly minor, was of profound significance. It provided a mechanism by which free will could exist in a universe otherwise governed by strict determinism. In essence, Epicurus offered a way to explain the unpredictability of events, allowing for spontaneous occurrences that diverged from a strictly cause and effect determination. Epicurus also revolutionized the understanding of the soul. In his view, the soul was not a mysterious, immortal essence, but rather a collection of very fine, fast-moving atoms. He believed that when a person dies, these atoms disperse and the soul ceases to exist in any conscious form. This naturalistic view served a dual purpose. It liberated individuals from the fear of divine retribution and the anxieties surrounding an afterlife, thereby promoting a life of tranquility and rational pleasure. By demystifying the soul and positioning it within the same naturalistic framework as the rest of the universe, Epicurus not only reinforced the tenets of atomism, but also made them deeply relevant to the practical lives of his contemporaries. From the intellectual flourishing of ancient Greece and the innovative adaptations of Epicurus, atomism's influence began to radiate outward, leaving an indelible mark on subsequent generations. In the centuries that followed, atomism found its way into the writings of Roman philosophers and poets. One notable figure in this transmission of ideas was Lucretius, a Roman poet whose work, De Rerum Natura, or On the Nature of Things, echoed the ideas of Epicurean atomism with poetic elegance and philosophical depth. Lucretius crafted a vision of the world that was both clear and accessible, a universe in which everything was composed of tiny, indivisible particles moving through empty space. His work not only celebrated the beauty of natural processes, but also provided a counterpoint to the mystical and supernatural interpretations prevalent in his time. Despite its early brilliance and expansive reach, atomism was not always embraced without resistance. With the rise of predominantly Christian thought in the later medieval period, atomism faced significant challenges and outright suppression. The Christian Church, with its emphasis on divine creation and purposeful design, found the materialistic and mechanistic view of the world unsettling. The idea that the universe and all its wonders could be explained solely by the movement of atoms without recourse to a divine creator clashed with deeply held religious beliefs. For a long period, atomism languished in the shadows, its radical ideas stifled by prevailing orthodoxy. However, the suppression of atomism was not to last. Enter the scientific revolution, a time of unparalleled intellectual and experimental fervor when the rigid frameworks of medieval thought were being questioned and redefined. The 17th century witnessed the revival of atomistic ideas, this time bolstered by empirical refinement and systematic experimentation. Prominent figures such as Gassendi sought to reconcile classical atomism with the emerging scientific doctrines of their era. Their work paved the way for later giants, names like Robert Boyle, Sir Isaac Newton, and John Dalton, who would develop our modern understanding of atomic theory. These pioneers were not merely echoing the ideas of ancient philosophers. They were actively engaging with nature, conducting experiments, and formulating theoretical models that laid the foundation of modern chemistry and physics. Modern atomic theory, as we understand it today, owes much to the centuries-long evolution of atomistic thought. The atoms described by Leucippus and Democritus have proven to be more complex than their ancient counterparts. Modern science has shown that atoms are composed of even smaller particles, protons, neutrons, and electrons, each governed by intricate forces and interactions. Moreover, the experiments and mathematical formulations that emerged during the scientific revolution have transformed atomism from a purely speculative philosophy into a robust empirical science. The journey from the philosophical musings of ancient Greece to the precise scientific models of today is a testament to the enduring power of human curiosity, critical thinking, and the relentless pursuit of knowledge. It is remarkable to think that an idea that began as a radical challenge to conventional wisdom could endure millennia, continuously adapting and expanding in response to new discoveries. Atomism's evolution is a story of resilience and intellectual bravery, one that mirrors the very nature of scientific inquiry, a constant quest for understanding, improvement, and sometimes even the courage to question. Throughout this narrative, we have seen how atomism has not remained a static concept, but rather has evolved with our expanding knowledge. The transition from a philosophical hypothesis to a concrete scientific theory underscores the dynamic relationship between ideas and empirical evidence. The early atomists provided a framework that allowed subsequent generations to ask new questions. What are the underlying rules that govern the movement of these tiny particles? How do they interact and combine to form the vast array of materials we experience in everyday life? And most importantly, what does this tell us about the true nature of reality? In addressing these questions, scientists and philosophers alike were compelled to look beyond the apparent order of the natural world and to seek deeper, more fundamental principles. The story of atomism is not just about particles and void, but about the spirit of inquiry itself, an intellectual adventure marked by radical ideas, rigorous debate, and the eventual triumph of reason. This intellectual journey illustrates the transformative power of human thought. An idea once marginalized can, through persistent questioning and empirical verification, become one of the cornerstones of modern science. In our modern age, the impact of atomism extends far beyond the boundaries of philosophy and into the realm of practical science. Contemporary atomic theory has not only advanced our understanding of the physical world, but also revolutionized industries, medicine, and technology. The principles that emerged from ancient atomistic ideas now underpin technologies ranging from nuclear energy to quantum computing, emphasizing how fundamental theoretical insights can lead to transformative practical applications. In a sense, the journey of atomism is a mirror of the broader evolution of human thought, from abstract speculation to concrete, life-changing innovation. As we draw this exploration to a close, we are reminded that the history of atomism is a vibrant tapestry of ideas that spans more than 2.5 millennia. It is a narrative that begins with simple, elegant philosophies and culminates in the complex, high-tech understanding of matter that frames our modern world. The evolution of atomism teaches us that knowledge is not static. It is ever-evolving, driven by curiosity, critical thought, and the willingness to challenge established norms. Today, the atom stands not merely as a building block of matter, but as a symbol of human ingenuity. It embodies our relentless drive to peel back the layers of mystery that cloak the natural world and to uncover the fundamental truths that lie beneath. From Leucippus and Democritus to Epicurus and the great scientists of the scientific revolution, each chapter of atomism's story is a testament to the power of ideas to transcend time, overcome adversity, and ultimately pave the way for the future. In reflecting on this monumental journey, from the philosophical debates of ancient Greece to the rigorous experimental inquiries of modern science, we gain a deeper appreciation for the enduring legacy of atomism. It is a story of bold hypotheses, intellectual challenges, and the continuous evolution of thought. As new discoveries are made and our understanding of the universe grows ever more sophisticated, the ancient wisdom of atomism continues to resonate, inspiring generations of thinkers and scientists to dare to ask the big questions. Thank you for joining us on this enlightening journey through the evolution of atomism. As we leave you with these thoughts, remember that the quest for knowledge is eternal, a journey that invites each of us to explore, question, and ultimately to appreciate the intricate dance of the atoms that compose our universe.